Let's wait a couple minutes for people to join me. We'll start at 3:05.
Okay.
Let's wait a couple minutes. I think we'll start our event. Hi, everyone. Thank you for joining us today. We're so happy that you're able to make it today. And we're also happy to have Dean over here with us to share his journey to transfer from art degree to data science degree. So we will be recording this session. So I know this is the working hours. So some of you guys may not be able to join now, but this will be recorded and then we will post it on YouTube. And then we also will send you the slides and then also the video recording after the event. So I will hand over to our admission officer, Sophia, to talk about our academy first. Sophia can go ahead and share the screen.
Great. Thank you, Joanna, for that wonderful introduction. And thank you, Dean, for yielding some of your time for my introduction here about the NYC-DSA. So my purpose today is to introduce you to our school and to answer any questions you may have. I realize that some of you are already enrolled, others of you are first-time visitors. So in order to keep the content relevant for a mixed audience, I'm going to keep the presentation high level. And if you have any particular questions you want to ask, feel free to drop it into the chat box or to reach out to me directly at my email address that I will provide you at the end of these slides. We want our participants to participate. So in addition to any questions you have, if you have any comments, feel free to interject at any point. A little bit about our school. NYC DSA is an academy that offers boot camps, professional development individual courses, as well as bundled individual courses, which qualify for bundle discounts. Our boot camps are offered in 2 delivery formats, one of which is in person and live streamed via Zoom. This one is 12 weeks long, and attendance is mandatory for the morning and afternoon lectures. If you require a bit more flexibility, we also offer the on-demand pre-recorded full-time and part-time boot camps. The content is the same between the 2 formats. The career services support is the same, as well as the one-on-one mentorship. We are very excited now to also offer the data analytics bootcamp. And with this bootcamp, so let me go over the delivery format first. We also offer the in-person, live streamed, full-time 7 weeks bootcamp and the part-time online 12-week bootcamp. The content covered in our data analytics bootcamp is actually identical to the first half of the data science bootcamp. And this is good for you because, especially for those who come from maybe non-technical backgrounds or those who want to dip their toe into data science and want a bit more flexibility before diving full into our bootcamp, you have the option to do so at an initial lower cost to you. And the tech assessment is also friendlier in that the grading rubric has been adjusted for data analytics. Again, the content is identical to the first half of the data science bootcamp. The career support is the same, and the unlimited one-on-one mentorship is the same. We are the only bootcamp that teaches both Python and R. Python is the language for machine learning, but R is also widely used in industry. It's very powerful, and we want to make sure our data scientists are well-rounded, and this will make you that much more competitive in the job search. The R courses comprise 40 hours out of the 400 hours as a data science enrollee, and the rest of the instruction is in Python. We have the opportunity to complete 4 industry projects, which will test comprehension of the concepts you learn during lecture. And you will, through these projects, prepare your portfolio for presentation to employers. One of these projects is the capstone project, which give you the opportunity to work on industry pitch projects. And this allows you to gain more flexibility in the data science community, because you can list on your resume that you worked on a project that NYC DSA is partners with. In addition, you will be added to the NYC DSA blog as a contributor, furthering increasing your visibility and increasing your credibility. And in this blog, you can list your projects, your GitHub links, your LinkedIn profile links, and this will very likely shorten your time to hire. We're known for our job placement support, and this is done through various channels, one of which was the aforementioned unlimited one-on-one mentoring support that you only receive from NYC DSA. Our competitors might assign you 1 or 2 mentors, and you're limited to 1 or 2 sessions during the week. With us, you get a list of their bios, and if they work at a job or in an industry that you're interested in, you can reach out to them, schedule these sessions, and in addition to homework and project review with them, you can ask them about inside information at their job, how to get your foot in the door. Treat these sessions as interview prep, as resume reviews. We have our career services advisor, who you will meet with regularly and who at least weekly meets with our partners. And on your behalf, she will forward your profile to them for positions that you've indicated interest in. You will be added to a job portal, which is exclusive to NYC DSA graduates. The recruiters in this portal are our industry partners who have indicated to us that they only want NYC DSA graduates. So again, that shortens your time to hire. In addition, after graduation, you will participate in a post-bootcamp study plan where you will work on coding interview question sets with your peers. You will work on polishing up your tech interview skills, your elevator pitches. You'll check in regularly with a faculty advisor to make sure you're on track. And we also offer live coding reviews, simulations. So you sign up for these. One of our industry partner recruiters actually sits in the session with you, and you will do a tech interview on the spot, giving you practice that way. We want to continually grow our network, so our relationship with you does not end at graduation, but afterwards as well. We have 2,000 alumni working across the globe, and our diversity is reflected both in our faculty and our student body. We've been consistently rated the best data science bootcamp, the best online data science bootcamp by SwitchUp and Course Report. This is a breakdown of the upcoming bootcamps. The in-person and live streamed bootcamp begins next year, January 3rd. If you want to start earlier, you can. And we offer the full-time and the part-time on-demand pre-recorded bootcamp, which begins November 8th and January 3rd. So we throw in an extra session there for you. If you're interested in the data analytics bootcamp, the start date for the part-time pre-recorded bootcamp is November 8th and January 3rd. If you're interested in the remote live streamed one, the start date is January 3rd. The admissions process is straightforward. You submit your application, you schedule an interview where the admissions officers learn more about your background in data science, your interest in data science, and we go through a behavioral interview. If all goes well, you'll be sent a technical assessment, which you have 48 hours to complete. You'll return it to us. We will forward it to our data science instructor, so we'll grade it, and within a week, you get a response as to whether you're accepted or not. It's recommended that you apply as soon as possible because you don't want to wait until the last minute. And if you do apply with plenty of lead time, you also have more time to do pre-work and apply for financing. We have generous referral bonuses. So if you enjoy if you enroll and in the future have a friend who mentions an interest in data science and you refer them, then you get $1,000 for each student that you enroll. So we have this in addition to another variation on it, and I'll be happy to share that with you if you reach out to me directly. This is all I have for the introduction to NYC DSA, and I will hand the stage over to Dean. Oh, let me actually share and this is the email, and I'll drop my personal email into the chat box as well. All right, thank you.
Dean, I think you are on mute. You're mute yourself.
Hey,
now we
you guys
can
hear
hear
me? All right, cool. All right, so I will share my screen now, and let me know if that's visible. It should say Dean Goldman, NYC DSA alum, blah, blah, blah. Oh. All right, so yeah, this is, hi, I'm Dean. I'm a NYC DSA alum, and this presentation is basically just like the story of my career growth as it started from when I decided to pursue data science, asterisk, kind of fuzzy, I like data, and then where it like kind of landed me today. There will be some like advice and some like lessons, some little bit of wisdom here and there, and hopefully it's relatable and can give you guys some guidance on where you stand and where you might like to go. Does everyone here have like sort of a programming background? Like just the very littlest have seen code before, have seen, you know, graphs before. If anyone hasn't, like, I think there's a hand raise thing that you can do. Be cool to just like see. But no worries if not. I'll try to break it down. If anyone has any questions by the end, please feel free to ask. So I'll just get started then. Okay, so the first slide I'd like to share is just a little timeline. This is not a technical diagram. It's just a timeline of like who I am. So I'll just kind of go through it and discuss like what my work and school life has looked like. So in 2017, I started. I live in New York City, and around 2017, I decided I liked data and I wanted to like get involved with learning to code. Like, so that's kind of why earlier I said this is just a really fuzzy thing I was interested in trying out. Like, I like data, I like code, it seems cool. I hear there's money in it. And at the time, as you can see, like I was working at in a restaurant and at various artist studios, doing, you know, with a degree in fine arts. So with that kind of degree and how it kind of panned out over time is that the money's less reliable, the work is less reliable. So, you know, I was supplementing that with restaurant work, which is like pretty difficult. So I had all this incentive to like switch up my career. So hopefully that's, you know, makes sense. So I decided to just start taking night classes, learning how to code in Python. This is just like, how do you do stuff in Python? It's not even like data science. It's not web programming. It's just like, how do you write a script? After that, I really liked it. And I decided to take like a semester long course. So I just signed up for the next time I could do went like a step up and do like a 2 to 3 times a week programming course. So by the time I finished with that, I was like, I really like data science and I want to get involved in this. So I was, so I signed up for the Data Science Academy and got in. At that point, I like went through the academy. It was a really transformational time. It was really fun, and you learn just an absolute ton. It's just really great. So So after graduating, I TA'd there for a little bit and was hired pretty soon after for one of the career fairs at the Data Science Academy. I met the team lead at Samsung for their ads department. So they just work for Samsung ads, and they basically like push ads around on all the Samsung electronic devices. And they have offices all over the States and in Korea too. So I was hired by them. And then there was actually like other offers and stuff too. That was a very fun time because you're like you're on the job hunt and you have like, experience now, you have like something on your resume that looks good. So you're like, wow, something might happen. And it did happen. And I worked there for 2.5 years. During that time, that was like a really data engineering heavy job. And more importantly, importantly still, it was actually a lot of like web development. So since I was building an app, the app needed to be maintained. So like that really mattered as well. So like hosting, basically your like data layers, but also your like updates, your ETL, like extract, transform, load processes in to support this application that serves that serves your client. And my client was essentially everyone who wanted to like buy ads on Samsung TVs. So you learn just a ton of like hands-on, like where does data need to go? Like how does it need to get aggregated? How does it, like, I got 1 billion rows. How do I do this in less than, a second? Like, so it's like you have this kind of thinking, you train your mind to do this kind of like engineering approach. But so after like a while, I took that job definitely because it was just, I'm not going to say no. I'd rather take this job than continue working at a restaurant. So I was elated, like ecstatic about this job. And then after a while, I was like, I really do like doing data science. Like engineering is great, but it's just like, it's definitely different than doing something like, modeling, or like, when you're modeling something, or when you're, even performing just exploratory data analysis in some domain. Like an engineering job, it's usually these things are really, the objectives are really laid out for you. So I'll get into that more. So after a while, I started like getting personal projects going, like wrote a blog just to publish some of my research and work, kind of like just pushing stuff up to GitHub all the time, and just started building my ML skills again, because I always just wanted to get back into that, and started applying for other jobs where I could like maybe, or just trying to get involved in other projects where I could get some more ML stuff on my resume. Because at this point I had Samsung on my resume, but like nothing with like proper ML work. So I was like juggling, and I also had just started school to get a master's in data science, because like, this learning thing is just never stops. You just have to keep going. So I was doing that and work and trying to get another job. And eventually I did get another job at a small startup, just some people my age actually who got involved in doing AI for recycling. And I'll get into that more, but that's kind of where I earned my first like proper ML stripes, so to speak, like got to do some ML work and push that code to production and see that run. And it's once I was able to do that and like get that into my system, and that really built up my confidence and my ability. And also like I could finally put something on my resume that said machine learning. And so I kept applying, but I had like, it was a little crazy time. I had like 2 jobs and school and was applying for more jobs. So like this was all over the course of like these 2019 to 2021. And eventually in 2021, I was hired at Kios, a medical software company that does like AI for oncology or cancer research. So that's where I am today, and it's been about 9-10 months. So yeah, that's the timeline, and this is like the same timeline, but just like what I learned. I won't go into it much because I'm realizing that it's a lot of language, but generally speaking, in the bottom and the beginning, your basic, like, what's Python, what's programming, what's an environment, what are loops, what are functions. So if these are things that like, hopefully these are things that maybe if like, this is either something that you're dealing with now or you've already dealt with, but that's kind of where I was right in the beginning. And then later it's like, how do you build a web app, and what's SQL, and why would you use that? And then later at the Data Science Academy, we had more mathematical oriented things, this is more of like the data science aspect of this, which is what is a probability distribution? What is a logarithm? What is a matrix? What's bias? What's variance, etc. These are all things that I did not know at the time. So it was like very, for me, it was very challenging because there's all these new words that I didn't understand. So, and I had to just figure them out. And I didn't have a math background at all. So it was just like, that was a little much actually. So I struggled with that definitely. But I had like a lot of coding savviness because I had taken the Python courses and really liked it. So I was like, I'm just gonna grind through this. So I did end up grinding through it, but it's definitely can be challenging, but don't be discouraged if that applies to you. Then there's so the Data Science Academy also, like I hear, has the Data Analytics Bootcamp now, which I think probably has like a little bit more time for you to learn some of the basics rather than push you along into more advanced stuff like machine learning, which can be like really challenging if you don't have the proper like prerequisite knowledge. So later, once I was at Samsung, you kind of get more involved as an engineer. You get involved in more of like software development. At least in my role, I was software development and database management. So you're gonna deal with things like, what are unit tests? Like how do you make unit tests? How much time and storage and computation should you allow for a particular product or a particular feature? And like how do you perform? One of our tasks involved a lot of like searching. People searched through our app for stuff, and so how do I make a good search bar? Like, you don't need machine learning for this. You can just have like a string similarity, and there's just plenty of different ways to do it. But like, how do you design one that fits your particular use case? So it's like, these are just all like kind of computer science questions mixed with like a little bit of math, a little bit of just like, it's more like, coding 101 type of things. And then later down the line, there were more ML oriented things I learned. Stuff like, how do you run a machine learning experiment? How do you evaluate it? How do you say, like, does my model have any predictive use at all? I've actually written models myself doing like personal projects where I thought like, oh, this 8%, and it's just like totally meaningless. So it's like, how do you become nuanced enough not to let the just the motion of like doing data science fool you and lead you nowhere? So how do you have like a perceptive eye when you're working with data, that applies everywhere, not just to machine learning. But and then some of the funner stuff that I've done along the way, especially at Kios, is learning about GANs, general adversarial networks, style transfer, encoder decoders, self-supervised learning, semi-supervised learning, and then I'm also so a lot of fun deep learning stuff I've worked on, and I've even got to dive into transformers a little bit, which are pretty cool. And At one point, we're very cutting edge. That's like kind of, it's just very fun to there's a huge gamut of things to learn. So there's I kind of go through everything I've touched on here. So let me go to the next slide and just cover a little bit more as a data engineer. I know that I'm talking a lot, so I'll try to be even more I'll try to be less long-winded. But if you're interested in becoming a data engineer, like the main thing is that you just are you're going to be valued for being like an efficient programmer and like a savvy software architect. So one of the main things as well too is that people really need your data that you're pushing around. You're in charge of it. It's your responsibility. So essentially, like the way I wrote it was that you're going to be facilitating multi-party access to real-time data, meaning like a ton of people are going to like reach your little storage unit where you store your data and are going to run with it, and then they're going to take your data and use it for some other task. So if you're inconsistent, they're going to take your inconsistent data and bring it downstream, and like someone's going to find out about that inconsistency, and it might be a client, it might be a customer, and they'll be like, you're giving us garbage, and that comes back up, and it finally comes in, and they're knocking on your door. So like the priority as a data engineer is like you need to be very like take full ownership of what you're doing with your data, and produce very reliable results. So don't take anything for granted or take any shortcuts. But the positive thing about data engineering, while there's while it does have this issue where you need to be very consistent, or else like you have to sit there until it's consistent, is that it's pretty easy to just start taking cracks at it. So any app you want to build, like you don't need to reinvent you can just basically reinvent the wheel. Like just build any app, build any website. You'll just learn, and learning about data engineering is a lot easier, I think, than learning about data science, which has more prerequisite concepts like math concepts that you need to ingest first. But it's the plus side is it's really fun, and it's easy to learn. So there's some ideas here. If you guys are interested, I can share these slides with you, so you always have like these suggestions. These are things that I did when I was trying to break into my own, break into my own or build some experience of my own. So one idea is you could try to build a database and store it remotely, and try to actually calculate your database requirements for something like let's say you want to track every time that you go out to eat. Like, how would you do that? And maybe build a budget tracker. Like I see what that looks like, and Google is your friend. You can always Google around like other, like build your own budget tracker Python. Like that'll definitely get you somewhere. So yeah, and another idea too is like if you want to have just like I know at the Data Science Academy they're big on web scraping, and that's because it's like you can find a lot of really cool data that way, and there's a lot of creative opportunities there. So cron jobs are really big for that. Like every night you're gonna run this program on your computer. That's a really good idea to just get you started with what the requirements are as a data engineer. So because you need to reliably push this data around. So right, I'm going to web scrape this website that is going to find me cheap rugs because I want to buy a new rug for my office. So it's like, then I got to scrape it every night and look for a sale. And then if there is like a sale that's under the threshold, I'm going to email myself or something like that. So that's what the program would do every night. And there's even more complex ways to store this information if you're not just interested in the price of rugs, but maybe other things. So there's just like a ton of opportunity to just try things out. But I'll keep moving on. So like I said before, at some point I was like just realized I really wanted to become an ML engineer. And this isn't to say that there wasn't ML opportunities in my data engineering role. It's just that I was ready for a new company. But I should just point out that like if you really wanted to like figure out an ML application in your data engineering role, it's definitely very possible. But it just wasn't like how it ended up working out for me. I did try it a lot. It's just harder to do that type of thing on your own. Learning ML skills requires, at least from my background as non-STEM, required more mentorship. And just more like I had some questions, and that like I wasn't going to be able to proceed until the question was answered. So those kinds of like big brick walls that you run up against, it's very helpful to have a mentor or just friends to be able to like tell you how that works. So what happened was I was applying around, doing little projects, and trying to put them and just finding like entry-level ML applications and applying to them. And then eventually I was hired by like a really small startup with what's called EvTech that was doing AI for recycling. And they were so small, they like could only pay me in equity. They were like younger than me actually. So I mean, and I wasn't a full-time job. Like I said, I took this job on top of working at Samsung. So it was kind of just like almost like a pro bono project. But you know, I think they were reaching out to investors and stuff like that. So they kind of they'll call it a startup, they'll call it a company, but really it's like, and that's what it is. But it's these two guys who are reaching out to people to invest and trying to have this proof of concept project. And they were working with two other engineers. One of them was happened to be another graduate from the Data Science Academy, which was really cool. But much older, like an earlier cohort. So, that was really nice. And it was just really cool to network with people, and we got to talk about like ML and like basically, I got to get my feet wet there in a more professional setting. And I think the next slide covers kind of what we did here. So I think, let me see if hopefully you guys this video plays all right, but this is basically like EvTech's technology. And so I got to work on the technology that produced, so image segmentation and classification and tracking for recycling. And our first like MVP, minimum viable product, was for like plastic bottles. So we wanted to be able to label different brands of plastic bottles and collect data on that and track as well. So this is basically my first foray into machine learning. I didn't author the entire like I wasn't the head of the ML department here. I was more like the junior ML developer. So I got to work under just really cool, smart people who were also doing this pro bono just because they liked doing it, I guess. So it was but it was really exciting. And any chance you get to just join something, I'd highly recommend it, because you're better off with chatting with other people than you are on your own. I think it can be very daunting to do this type of thing on your own. I know that like I wouldn't have been able to do this by myself at that point. But yeah, so let's see if this next slide's gonna go. Okay, so yeah, so my best advice for like basically like you're starting from wherever you're starting, but you're interested in becoming an engineer or becoming a data scientist, is you just have to do projects, and you can start small, start with really simple projects, and then maybe try to increase them in complexity. There are steep learning curves everywhere you look, especially if you don't have a background in STEM. It can just like everywhere you look is like you're like in a valley or something where everything just looks horribly daunting. But you'll become more comfortable with these skills the more you train them. And really the goal is to be comfortable with doing these things, because that's what people who are going to hire you are just looking for, generally speaking, that you're comfortable in these environments. Not necessarily that I can explain accurately like some like definition of like some detail about like kernel tricks that like is gonna, it's not necessarily you need to have like specific knowledge, but that you're comfortable enough in dealing with the overarching themes. I don't know. I can get into that more, but anyways, the like methodology I felt for starting projects is actually, it can be a little bit difficult. It can be discouraging to just like come up with web scraping ideas on your own, or come up with like, try to look around like thinking, what am I gonna do machine learning on or whatever. So it's probably easiest just to start with something that's been done before. So I just grabbed this big archive of machine learning data sets that are like from a university. And essentially, like, if you're interested in learning some basic modeling, you should just run through every single data set in this link and look for convenient model implementations online. And if that's easy, you can try to hand code it yourself. And then, if you like, you can always kind of work around with just a toy data set that you have. These are designed for, regression or classification. So I'd highly recommend just making it easier for yourself, and just start looking at data sets that are already there for you. If you just need somewhere to start, it can be really a bit of a challenge to go and try to fetch your own data. I've done that a lot. I actually have like kind of a little bit of like a horror story of like trying to come up with my own machine learning project using some data I scraped from the US Geological Survey, and trying to predict like how many fires were going to happen across the state of California, like depending on the location, depending on the time of year, doing some like time series forecasting. And like, that's just very complicated, and it can be, you can bite off more than you chew very easily, I think. So that's just, be wary of that, and just start small. Like, I have a problem where I like get excited about the machine learning. It's going to happen. The best model is going to happen. It's going to be so cool. And then I just, I think it's, you get starry-eyed or something. And really the idea is just to learn slow and incrementally, and start with like small little demos. So that's kind of the data science side of things. With data engineering, I would suggest you kind of can get started, because especially if you already know programming, it's really good just to try crazy stuff. But for data science, like, don't try crazy stuff. And this is mainly for like non-STEM background people. So if you're a math and stats PhD, you can do some data science stuff. Like, try crazy stuff out, sure, if you like. But like, for me, I was just like, had like a year of programming skills, had like, had done a couple personal projects. And that's like, you want to start small. So this is kind of where this next slide comes in. So these are just some fundamentals that I'm listing here that I thought are helpful as prerequisites to learn. Hopefully they'll be useful to you. If you already know them, this should just serve as like a, our encouragement for you to keep going, because I didn't know much about any of these things at all until I had was exposed to them at the Data Science Academy, and then like got to develop them a little bit better as a student at Johns Hopkins. So like, really, hopefully that if you know any of these things, that's a really good starting point. I'm seeing that you guys are writing questions. So I'll get to that right in a second. But I see your questions, and feel free to write in there. Okay, so the first thing is mathematical notation. This is just like Greek, basically. I didn't know what a sum looked like until like the Data Science Academy, where like, you know, like someone next to me at the Data Science Academy, I was like, what's this? And he was like, did you take a math class? It's a sum. I was like, oh, I only know sum when you write it in Python. Like everything to me is Python. So I could only speak data science in terms of code, which was kind of funny. But if you learn mathematical notation sooner, a lot of things will become easier for you because you'll just get it in your head how you have to like, oh, I just need to sum over these things. Like that's important for a lot of like aggregation. And I wrote this stuff down pretty like thoughtfully. So I'd recommend if you are liking these slides, I'd recommend to like go through it and one at a time, like learn how I'm blanking because it's presentation, but learn how Sigma, is it Sigma? I don't remember. Then move on to applying it to a metric like cosine similarity. So use it in practice. You know, so just once you have that down, you can get into matrices and matrix operations. That's a little bit, and the way I had broken down matrices was just essentially like, if you're familiar with a CSV file or an Excel spreadsheet, it's kind of like a matrix, right? Like like you got your rows, you got your columns. So that's kind of just that you're getting started. We all kind of know those types of things. So we're all getting, so that's a good place to start. And then functions, derivatives, integrals, exponents, and logarithms. This is like your basic calculus. Very important to learn for data science. And then finally probability, which is really useful for like, it's useful because one, a lot of interviewers ask you questions about probability, and two, it's actually very useful for structuring problems. So so a lot of companies really rely on or they really leverage statistical probability to make like data products. So we're in that kind of business. I'd highly recommend it because I've had like multiple like people ask me probability distribution questions, and once I realized that the question is like, oh, it really relates to them because they deal with customers, and it's saying that they're trying to model how many customers come back with a problem. Like that's very common when you deal with customers. The customers come back and they want something. There's a problem, so they're trying to say how many complaints do we get in an hour? This is kind of like a classic like probability problem, which I'll get into more. So this is just more exercises for getting better at data science. Hand code algorithms. If you see something that you want to try out, you can use like sklearn or whatever to get your k-means clustering done. But you can also try doing it by hand. That will give you a lot of like down-to-earth knowledge of like what's happening. And everything ultimately is coded by hand, so you can learn about like source code and things like that, and that's very useful and it's very healthy to do as someone who, like, you know, if you want to just borrow algorithms and use them as a black box, that's one thing, but it's not really going to get you that far. I think it's much better to really be curious about what's going on, and this is actually contrary to a lot of advice that I got when I was young, when I was kind of breaking into the data science or breaking into like the programming world. I went to like a conference once and they were like, you don't need to know that much about what these things do, you just apply them. And he had this like computer vision demo he was doing, and he was using he was using Keras, like the wrapper for Google's TensorFlow library, and just like making this awesome like image detector. But it's like he designed this demo for it to work. So like, it's just, you gotta really know what you're doing. It's not gonna work unless you are very, very comfortable and can kind of spin the concepts around your finger kind of with ease and comfort. So that's really the goal. It's just to be very comfortable with how the inner workings are. And then you can also try out LeetCode. I have done this a little bit, and some of my friends have done it a lot, and I've seen their minds for data and for structures and for algorithms improve a lot. So it's just really good to try out LeetCode. I'd recommend it. If you want to learn better coding skills, and it's just, and you can it'll just give you classic computer science things to try out. And I've gotten a lot of LeetCode problems as interview questions and failed most of them. So that can be daunting. I remember at the Data Science Academy, I was the first, one of the first. No one's keeping track, but I had gotten this interview right out really early, and I felt super big. I was like, oh, I'm the first to go. I'm getting hired. And then immediately I sat down in the office, and they were like, can you hand code merge sort? I have this array. Can you sort it? I was like, and I didn't really have my I didn't know my sorting algorithms, so I just was like sort parentheses array, so it really, the idea is that you need to understand the inner workings of what a sorting algorithm is. That people will ask you about that if you're getting interviewed for a job at one point or another. Okay, so kind of switching topics to getting more involved in doing data science or even just analytics in general. Sometimes there's this idea that we just really want to dive in and then put all the functions together and run the program, and then bang, all the results come out, and it's awesome. And it's very satisfying for me too to see the code execute. But really, it's important to become very familiar with the domain and the data itself. So you need to be able to explain your data set in plain spoken terms. Where does it come from? How does every single nodule or every node in your data set appear, or node or row? How does every row get generated? If you can't explain those things, it likely means that you're not able to track this data back into reality very well. That's very important to do. If you can't track it back into reality, you're going to miss a lot of the key signals. So data can look very odd for one reason or another because of the phenomena of its generation. So sometimes I remember when I worked at Samsung, there'd be some people had just watched sports for ever, and it's just they don't turn it off, and it's oh, these Samsung TVs are obviously in a bar. So it's you just have to pay close enough attention to where you're not letting your distributions get skewed by obvious outliers, things like that. And if you can speak in plain spoken terms about your data like that, that's a really great thing to be able to do, because it means that you're going to be able to manipulate it better. And you can also, there's just more complex things to peel apart too, but you want to just definitely ensure that you're not taking anything for granted with your data set. I remember back to the horror story with the fire data set that I was using. I was pulling all of this data that I thought was well, it's very complicated. I won't go near it, but anyways, just be very cautious about what about the structure and nuances of your data set, and don't and the last thing about this slide is that models don't neatly fit one data set to the next right out of the box. So you need to deeply understand your data set in order to model it. So it's you can't just necessarily apply ARIMA to your data set that has a year value in it just because there's time doesn't mean it's going to model well with ARIMA, or it doesn't mean you can, So there's just plenty to get wrong here. So it's just best to not be too starry-eyed and think that, okay, I'm just gonna shove this into a model and it's gonna give me what I want. That's definitely not what you want to do at all. And I know it's frustrating because we want to see the code execute, but it's important to really just kind of love the data itself and learn about it and become close to it. I listed here some ML engineer interview questions that have all happened to me. They've all happened to me. I've received these as questions. Let's say that. So the first one is obviously, what kind of machine learning projects have you worked on? This is just, it's really important that like if you don't answer this very well, then they'll be like, this person hasn't worked on that many machine learning projects, and they probably won't hire them. So that's why that's like the reason, the impetus to just like get some products under your belt and be able to talk about them. Even if it's small, if it's like, you know, it might take a long time until you have a good project that you want to share, and you'll learn from experience. But like these things do take a long time. Like I said, my timeline started like in 2017, and it's been a lot of work every day since 2017. But yeah, but it's definitely super worth it. It's very fun. But I'll keep going on these interview questions. So this is a classic kind of Bayes theorem question. So a patient goes to see a doctor. The doctor performs a test with 99% reliability. That is, 99% of people who are sick test positive, and 99% of the healthy people test negative. The doctor knows that only 1% of the people in the country are sick. Now the question is, if the patient tests positive, what are the chances the patient is sick? So it's like, you would assume it's 99% because we saw the number 99 up there, but I encourage you to go and check out the this article, what is Bayes theorem, and just get acquainted with how that works, marginal probabilities. And later down the road, I got these questions about these like call center problems, which are very like you know, you want these are really fun ones to get right, so you want to get these ones right. So I'll skip through the second one, but just go to the third, which is actually one I got. You are on hold with the customer support line. They tell you there are 5 people ahead of you. You assume that a normal call is a minute long. How would you model a probability distribution of time it will take for your call to be answered? What is the probability your call will be answered in 5 minutes? So, you know, it might be that you would add together 5 1-minute long calls, and you just can expect that you're going to wait 5 minutes, but it might be something else. So you want to you might want to model that with a I think with a gamma distribution, but it could just be the sum. Anyways, this is like a classic probability problem, and I'm just kind of blanking right now because I'm in presentation mode. But anyways, so and like they're just going to quiz you on your ability to like describe certain vocabulary. So like precision, recall, specificity, like, and it can be very difficult when you're on the fly. Like even now, I'm not even being judged. Like no one's trying to hire me. Like I'm having trouble like wrapping my head, or like being able to super efficiently explain everything that I had written down earlier. So it's just, yeah, it can be a little bit tricky. But data engineering questions are less math and probability oriented. Usually they're your like lead code problems, and then they'll quiz you about your like database and application design like approaches. So like, you know, they want to know what your thought processes are, and then sometimes they'll even give you a toy data set, and they'll say, hey, I need you to build a directed acyclical graph, a DAG, that performs some type of data transformation and loading, ETL, on that sample data set, and then you just got to get saved to a SQL server, and then you got to put it in a Docker container. Like that's happened to me like 3 times. So definitely, like if you like that kind of work, I would practice any of these interview questions, and it's time well spent. So final tips are to just work methodically and go very slowly. Prioritize that you pay attention to your data and don't just like do data science. And most importantly, find mentors and friends. It's super important to it makes the learning process easier, and it's really is like a social thing. You want to be learning like amongst people. That will make you a more well-rounded that'll give you a more well-rounded mind. And then also some people don't know this, but it's super useful if you're like debugging something. And you're using Python, obviously. And if you want to just like, so if you want to walk through like some script, some piece of code line by line, and see how the variables are changing, or even just print something out, you can just add in pdb.setTrace, and it'll like turn your program script from your terminal into a shell. And you can just like, every variable that is in memory at that time will be accessible to you. If you already know this, great. But some people like didn't know this, and it was some people I knew who I thought was like that. You should know this, and they didn't. So thought I'd share it here, because if you ever wanted to like tired of like adding crazy print statements to your code to try to like debug something, PDB is helpful. So you can even hack this into your third-party libraries and add it in there if you want to like hack into like sklearn's random forest and say like, what the hell are they doing in there? So the only thing is that you can't always just put it anywhere. If it's like you're running like a multi-processing code, like it's gonna snap. You don't want to. It's gonna break. So be careful with it. Okay, that's it for me, and I can. Thanks for listening. I hope it was good. I'll get these questions. So Sandra asks, what data science tools would you recommend beginners to start off? I would start with NumPy. I think that's sure. I would start with NumPy because that's just your basic like matrix operations, and you can do aggregations that way, and just like put rows of data together and work with shapes. And that's really important. And then I think after that, and that's like really fundamental for if you're working in Python. And then after that, I would probably go into, if you might want to just get comfortable with like some data sets, and I would break into some different data sets and see if you can manipulate them using like pandas or NumPy. And data science tools, just depending on what you want to do. Like it might be, if it's machine learning, sklearn has really fantastic, easy to use libraries that run on your CPU. You don't even need like something heavy to get them started. So sklearn, NumPy those are the best Python data science tools. But also like there's others too. But I think generally speaking, I would stay away from stuff that like is like a wrapper or like a software as a service for data science. Stuff like Looker, I think, probably does some stuff. Like I know even like Google Sheets has like regression. Like it's better just to like learn how this stuff works on a tabular level, like or on like like a like more low level. So the lower you can go, the better. So the next question is, how long did it take you to decide to step into the data science industry? Probably it's a slow decision-making process. It's there was a lot of doubt. I was like interested in doing art for a long time, and then I got into coding, and I was like, well, maybe I'll do like coding for art. Maybe I'll like try to hybrid this, and then everything just sort of pointed to just like get better at this thing. And you know, it didn't. It's kind of a difficult. Yeah, it probably once I got into a class, I think, and just saw where and just saw what you can do with stuff. I think once I was in the Data Science Academy, that's my official answer, is that I realized like, wow, this is so cool. And that's when I really fell in love with data science. So I think that I always liked it because it's a cool word, and I always liked coding. And then the more you learn about it, the more you fall in love with it. And I think that that's like, it's a process though, for sure. You don't always have clear answers in the beginning. I remember my answers weren't clear. The next question is there a variety of people of different ages and backgrounds working in ML, or is it more of a startup culture? A lot of different backgrounds. But generally speaking, the more senior people are older. It does skew towards younger. And you're going to have, but it's like in terms of culture, everyone's very different. There are a surprising amount of non-art majors in like the data field at large, like not just data science, but engineering and coding in particular. Like my coworker, she was in fashion and then switched over to data engineering. Another one of my friends. He was like a physics major and then switched into front-end programming. And then I've had, countless other, not countless, but I've had quite a few other friends switch from art into more tech-oriented things, into more tech-oriented fields. And then my recent coworker, actually, he was with us only for a little bit of time. He was a violinist that switched into data engineering. So it's everywhere. You see these kinds of career transitions everywhere, and that's why it's like you want to just make this thing as like social and friendly as possible, because there's a lot more people than you think that are in the same shoes as you, and it can be really good to connect. Cool. And so I'll read this next one. Of your graduates at NYC DSA, do most people go into data engineering or data analysis before landing their first data science job? Is it hard? I'm going to interpret that. Is it very hard to land a data science job right away? Yeah, I think like, especially if you don't have like a strong STEM background, it's going to be, you got to kind of lean into what you're good at, to like what you're best at to get your first job. So my first job was just because I was like, had a lot of practice programming, and I built a bunch of web apps by myself. And I'd actually done a pro bono, like I worked for a tutoring company, again, not for pay. I found them on a volunteer organization, like job panel board in like 2017. And I was like, I need to get some programming skill, like some coding work on my resume. So I like built them a tutoring schedule database. And it kind of sucks in the beginning because you like will take work for no pay just so you have something on your resume, but you need that experience. And in the end, like it really is worth it, because it's and also you have some freedom to choose, like if you don't have to, you can do something cool, which is nice. So I thought that working for the tutoring company was just fine. I like really liked helping them out, because it's like an after school tutoring program for like kids who needed it. So I was happy to do it. And like there's other projects too, like open source competitions a lot of them are like nonprofit driven. I don't know, it's fun. Oh yeah, anyways, that's kind of a digression, but yeah, I don't know what most people do or not, but what I did was like my first role was data analysis heavy. Like there's a bunch of data coming in on people watching ads and people like watching TV shows. And so it's like, I need an average of like how many people saw the ads. I need an average of how many people saw the show, like very, very basic data set aggregations. But the problem is that you need to do that every single day, and you need to put it in a dashboard. So like these basic fundamentals are really important. And there's a lot of jobs like that. Believe it or not, the world like is not nearly as automated as it could be. So there's just a ton of jobs out there that need that for like doing data set, like data engineering, sorry. So yeah, that's the low-hanging fruit, at least for non-STEM people, I think. And data science, it takes longer because you just need to slowly get into it to a point where like you're gonna still Google stuff all the time, but where you can navigate Google a little bit better and then like build some good projects. And even at work, like today, I'm like, I gotta Google this. Like, I mean, I have no shame about it. It's like, of course I gotta um, look something up. I'm not gonna keep this all in my head. I only have like a tiny window of like what I can keep my mind around. And this whole like screen is like the area, like the whole space of things I can learn. In reality, that like it's like astronomically small. That's my brain, and the screen is like the space of data science knowledge. So you're just never gonna know enough at once. So you gotta use tools to help you. But it takes a long time. So sorry for digressing. The next question is, having caught up on STEM skills, do you feel your arts background helps in data science at all? It's funny. There's like a lot of there's a lot of, I guess, to answer that a little bit, in the sense that like I majored in painting, and one thing I remember very well is that like with painting, like you want to be very like thoughtful with what you're doing, because especially like with if you're trying to make like a nice little piece of art, you know, if you spill something or spray paint everywhere in an accidental fashion, if you didn't intend to do that, it's not going to look right, and it's so you need, and it's expensive because paint, and it's like materials are expensive. In computer science, it's often the case that like sometimes these things are not so expensive because just computation is luckily very cheap, but you need to be very thoughtful with the way that you craft, like the way that you piece together your pipelines, the way that you piece together your algorithms. So yeah, sometimes I think about it a little bit like piecing something together, like strategizing. So there's definitely like a craft, something that I got out of. So out of my background was just the sensitivity to taking care of your craft is important, and being methodical and slow and paying close attention to what's actually happening is important. Those are things that are cultivated at like my from that I cultivated in my arts background that do work well for data science. But they are really different parts of your brain, for sure. If any of you are artists, it's like the first thing I heard in my night class was like, it's not at all like art where the answer is subjective. Like he was teaching us programming, so like he's like, this code is gonna work or not. So there's just certain things like that are very, very different, and it's important to realize that it's just a different domain entirely. So, but it's I definitely think that like one thing, yeah, it's a different domain, but you still want to make it like it's nice to be able to be I guess having I don't really know other way around it, but so it's nice to not be like totally like engineering mindset about everything. Being able to, or having at least like the orientation where I like to be plain spoken about things is very helpful too. Okay, so I probably talked way too long, but
Yeah, thank you, Dean, for sharing your career path. Oh, I just
they,
found out there is one more question in the Q&A sessions. Do
oh,
you,
cool.
do
Yeah,
you
sure.
specialize work in a particular area of ML, or are you active in a broad range of ML topic? That will be our last question for today.
Sure. Yeah. And so my specialty right now is in computer vision. So we also are at our company, we do a lot of deep learning, but so that's definitely whatever job you have, you'll definitely have some type of specialization. It's not the whole gamut of data science. So but yeah, so that's what I'm doing right now, and for that particular subset of data science, there's just so much there. So like I said, the space is huge, and then when you finally get down to what you're doing, it's some small subset. So it's that's one thing to remember about how this field is. Cool.
Yeah, I think that will be all the questions for today. Thank you guys for coming, and thank you again for sharing your career path. We will share the slides and video recording in the follow-up emails, and we have a lot of upcoming events, different topic, and then also some workflows. We'll talk about like Python and pandas. So if you guys are interested, you can follow us on webinar. And yeah, thank you so much. And
Thanks.
everyone.